This is Unit 5, Lesson 2. And today we're going to be solving, we're still going to be on quadratic equations. So solving quadratic equations by factoring. Now, the solution still has the same meaning. We're trying to find where the graph crosses the x-axis. But instead of graphing, we're going to find the solution by factoring. So the way that we're going to find the solution is different than the last lesson, but the meaning is the same. All right, so let's take a look at number 1. The directions will say solve. Now, if you notice, this doesn't really look like a quadratic equation, but it really is. This is in factored form. It's already factored. So the first couple of problems we're going to take a look at, the problem will already be factored, so we don't really have to do that much work. What we're going to do is take each factor, set it equal to 0, and then solve for the variable. So I've got two factors. I've got x minus 3 and I have x plus 4. I'm going to take each one of those factors and set it equal to 0. So I'm going to take each factor and set it equal to 0 and then just solve. So I've got x is equal to 3 minus 4 here, x is equal to negative 4. So if I were to graph this quadratic equation, it would hit the x-axis at 3 and negative 4. The way that we're going to solve these are different, but the meaning is the same. Let's take a look at another one that's in factored form. This is a quadratic equation. It may not look like it, but it's already in factored form. So I'm going to take each, just like we did in number 1, I'm going to take each factor and set it equal to 0. I've got x is equal to 0. Now this is a factor. It may not have a plus or minus, but it's still a factor. So x is equal to 0, and then x plus 8 is equal to 0. Now I can't do anything with this. It's done. It's solved for. And you can have 0 as an answer. 0 is on the graph. It's this origin. That's fine. Minus 8. I've got x is equal to negative 8. So if I were to graph this quadratic equation, it would cross the x-axis at 0 and negative 8. And another way you can check it is if I take either one of these numbers and substitute in for x, it's going to give me 0. If I substitute in negative 8 plus 8 is 0. 0 times negative 8 is 0. If I substitute in 0 here, 0 plus 8 is 8. 8 times 0 is 0. That's the way you can check that. The next few problems we're going to take a look at will not be in factored form. We're going to have to factor it. All right, I've got y squared plus 2y. This is not in factored form. We have to make it look like number 1 or number 2. So the first thing I'm going to, whenever I need to factor, the first thing I think of is there a GCF? Yeah, there's a GCF. The GCF is y. So I'm going to take out the y. Remember, I'm going to divide. When I say take out, that really means divide. So I've got y. That's my GCF is y. When I divide, y squared divided by y is y. 2y divided by y is 2. Now this looks just like number 2, what I've got up here. Looks exactly the same. So I'm going to take each factor, set it equal to 0. I can't do anything here. I'm going to add 2 here. Y, whoops, let's lift that up so you can see that. There we go. So I've got y is equal to 0 and y is equal to 2. If I were to graph this, it would hit the x-axis at the origin and at 2. Even though it says y, it's really the x-axis. Next one, number 4. Let's take a look at it. I've got x squared plus x minus 6 is equal to 0. Okay, this is a trinomial. First thing I'm looking for is a GCF. Well, I don't have a GCF. Next thing is I'm looking to see how many terms there are. There are 3 terms, so the next thing I'm thinking about is, can I factor this trinomial? All right, let's see. X times x gives us x squared. Now I need to think of 2 numbers when I multiply them together give me a negative 6. Well, I could have negative 1, 6. I could have 1, negative 6. I could have negative 2, 3. I could have 2, negative 3. Let's take the sum. I've got 5, negative 5, 1, and negative 1. I'm looking for that number, which is 1. Remember, I'm looking for one of these numbers to match the middle number. Now, there's no number in front of that x. That really means it's a 1. So I'm going to take one of the x's, put it with the 2. The other x, put it with the 3. So I'm actually just rewriting this in factored form. Now I'm going to take each one of those factors and set it equal to 0. So I've got x minus 2 is equal to 0, x plus 3 is equal to 0. Add 2, I've got x is equal to 2. Subtract 3, let's lift that up a little bit. I've got x is equal to negative 3. If I were to graph this quadratic equation, it would hit the x-axis at 2 and negative 3. Let's take a look at the next problem, number 5. Number 5, I've got, let's do a squared plus 8a plus 16 is equal to 0. So a squared plus 8a is equal, plus 16 is equal to 0. All right, first thing I'm looking for is a GCF. I don't see it. Let's factor the trinomial. I've got 1 and 16, 2 and 8, 4 and 4. Let's take the sum. I've got 17, 10, and 8. That's what I'm looking for. So I've got a plus 4 times a plus 4 is equal to 0. Now if you notice, it's the exact same parentheses. This expression's the same. Unless you really like solving equations, you only need to take one of them and solve for 0 and solve for a. You're setting it equal to 0. That means there's only one solution. If you remember when we were graphing quadratic equations, or we were solving by graphing, when there's one solution, that means it's your vertex that's right on the x-axis. So that means if I were to graph this equation, the vertex would be negative 4, 0, and that would be your solution. Let's do one more. Number 6. I've got 9x squared plus 4, or 9x squared minus 4 is equal to 0. All right, first thing I'm looking for is a GCF. I don't see it. The next thing I'm looking to see is how many terms there are. There are 2 terms. So differences of squares, let's try it. Hopefully both of these are perfect squares. Yep. I've got 3x and 3x, 2 and negative 2. So I've got 3x plus 2, 3x minus 2 is equal to 0. Now I have to do 2 of these. It's not like the previous problem. The previous problem, both of them, it was the exact same thing. Here, they're almost the exact same expression, they're just different signs. So I still have to set each one of them equal to 0. When I solve, I've got x is equal to negative 2/3. I've got x is equal to a positive 2/3. So if I were to graph this quadratic equation, the graph, our U-shaped graph or our parabola, would cross the x-axis at negative 2/3 and 2/3. And that'll be really hard to tell if you were to graph that. I don't know if you'd be able to exactly pinpoint that it's negative 0.6 repeating or 0.6 repeating. But it would cross the x-axis probably, well, if you looked at it visually, it would probably look at negative 0.5 and 0.5. But it should be negative 2/3 and positive 2/3. And that is Unit 5, Lesson